Hi, my name is Dave. I'm with VID, and today we're talking about a very unique, very useful locking system called the SoPLC, or Sliding on Pivot Locking Clamp System. Let's get into it. Now, the easiest way to think of the SoPLC is as an external skeletal fixator, except it's on the inside. Now, what do I mean by that? We're going to go through the SoPLC acronym to take a closer look. Conventional bone plates have fixed screw holes that determine your screw placement. So inevitably, after you place your plate, one of your screw holes is going to be over a bad area like a fracture line, a joint, etc. Now, we fix this limitation. The S in SoPLC stands for sliding because you can now place your screws wherever you need them by sliding the clamp up and down along the rod. This gives you incredible flexibility on even the most complex cases. And you also have no empty screw holes, which can create stress risers or weak points. A common failure mode for locking is pull-out failure, which is when the screw is kind of yanked out and strips the bone. So this occurs in part because of how forces are distributed when screws are in parallel with each other. And even if you can achieve some polyaxial locking insertion, typically your screw holes are in line, so your screws end up stuck in a divergent orientation. With this system, you'll have many more options. So the P in SoPLC stands for pivot, because you can pivot your screws around the rod to change their orientation and decrease vulnerability to pull-out failure. Angle your screws to diverge around the central axis of the bone. Place screws in parallel by lining up the clamps on the same side of the rod. And if you're really getting creative, you can even install the clamps to diverge for something like a back surgery. So in addition to screw location, you can also control orientation without any plastic or permanent deformation of the clamp. Now, the fact that there's no permanent deformation brings me to the LC in the SoPLC. LC, of course, stands for locking clamp. Our locking clamps lock with standard AO Cortial Screws through a spring-loaded mechanism that causes no permanent deformation. This means if you don't like where your fully inserted screw is, you can easily remove it, slide the clamp somewhere else, reinsert the screw, and do that as many times as needed during surgery or later if the implant has to be removed. Now, how it works is the clamp is designed with a smooth, sort of bowl-shaped top to seat the head of your AO Cortial Screw and a negative threaded bottom to accept its threads. As the screw advances through the clamp, its head will make contact with the smooth top, and the threaded bottom of the clamp will provide the equal and opposite force to elastically compress the clamp around the rod. Now, our rods also undergo a special surface treatment to enhance the force of friction, ensuring clamps will never slide. Rods also offer the added benefit of having a circular cross-section, allowing you to contour the rod across multiple axes, as well as distributing cyclic forces across multiple axes. So your plate isn't cycling across just one plane like your standard plate geometry. So that's the basic overview of the SoPLC. Some important closing notes. The system locks with standard AO Cortial Screws, which are much more cost-effective. It's a 2.0, 2.7, and 3.5 locking system. And really, you're not going to have to waste a bunch of money on specialized equipment. The sterilization tray is nice to have. Pictured here is the more compact version. There is a larger version that fits the rod bender. So the sterilization tray is nice to have. You might want your universal rod bender handy. Kind of get these anywhere. You already have the screws. So essentially, all you need is one of these cuttable rods, a few clamps, and you're ready to roll. So that's it. If you thought this video was useful or interesting, give it a thumbs up and subscribe. You could also check us out on Facebook, Instagram, and if you have more detailed questions about the SoPLC, check out the links in the description or visit veterinaryimplantsdirect.com. We'll see you next time.